welcome everyone. This is the first of a series of events we're doing around the world, and the theme is Meet the Startups. And it's actually great we're doing this in Switzerland because our first event in Switzerland back in June 2018 was actually on the theme startups. We had a Delft alumnus who founded a company, and we also had a Twente alumnus who was an angel investor, and that was hosted at, what is the Zurich University of Technology called? Mechthild.
ETH.
Yeah, of course.
Yeah,
of course. Yes, and this wasn't a bad camera, by the way. The reason it's dark is at 10 o'clock, they wanted to kick us out of the building during our borrel, and they turned the lights off. Little did they know that for Dutch people, that just encouraged them more to stay. So we had a great event there. And then a year afterwards, November 2019, we had two wonderful events, one at CERN, the first alumni gathering ever hosted within CERN, and after that at Google. And a year later, more or less exactly a year before today, we had a virtual event for our alumni in Switzerland. So these are some lovely views of our campuses. Now for the Delft people among us, this sort of looks familiar, but it doesn't look familiar. Delft people have had a lot of time on their hands, so they recreated parts of the campus on Minecraft. So that is a Minecraft version of the TU Delft campus. And if you look at Twente, that is also simulated photo, but it actually looks pretty real. That is the new blue square that was opened in front of our campus hotel just 6 months ago. Otherwise, Eindhoven and Wageningen have remained more or less the same. Here are the hosts we have tonight. My colleague from Delft, Mechthild. Mechthild, say hi. Going once, unless you disappear.
Everyone, yeah, sorry.
Myself from Twente, and unfortunately our colleague Denise Spiekerman from Wageningen couldn't attend tonight, but we will doing our best to also be ambassadors for Wageningen. And we have two other colleagues from Delft, but they are busy letting people in, so I'm not going to bother them, but that would be Anouk and Janneke. Let's see who's in the audience tonight. So I'm going to do a poll. I'm launching the poll now. And the first question is, how long have you lived in Switzerland? And if you don't live in Switzerland, choose the option, I do not live in Switzerland. Then we're curious about how many people have been to an alumni event before. So answer yes, but only virtual. No, I remember the good old days when we had free beer. So yes, I went to an online and offline, or no, this is my first time. And finally, since the theme of our event is about startups and entrepreneurship, we're curious what describes you best in the context of entrepreneurship. So if you could answer that. And I see we have a bit over 50% of them voted, so I'm going to give it 10 more seconds. 9, 8, 7, we're reaching 80%. 4, 3, 2, 1. Let's end the polls. And let's share the results. Cool. So 4 people actually have moved in the past 6 months to Switzerland. Then about a quarter have been 6 to 2 years, 6 months to 2 years, about another quarter, 2 to 5 years. 12%, 5 to 10 years, and nearly 30% over 10 years. And yeah, 6 people, I do not live in Switzerland. I assume that some of us support people. Have you visited an alumni event before? Oh, wow, 59%. This is their first time. So we're really happy to see you. And 36% yes, online and offline, and 5% yes, but only online. Interesting fact, after COVID, we do plan to continue also doing online events alongside our traditional events, because we find this is a great way to get people that are not in the locations we visit. So we're not going to be stopping using the online events. And what describes you best? 42% say, I think startups are cool. Yep, I totally agree. 70% work for a startup. 24% are interested in working for a startup. Ooh, we have 12% that are potential investors in startups. Interesting. 41%, I'm here to have fun. Okay, good to know. What are we doing tonight? So Rick Slederhar from the Dutch Embassy will give some opening words. Then we're going to have updates from the universities in the context of entrepreneurship. Then our talk by Chester, and finally the virtual Borrell. This is my slide to remind me, this is Rick's moment to say a few opening words. And I took some pictures from the embassy social media feed. The photo on the left side is from their pop-up consulate, which I thought was really cool. They just go to a restaurant and help Dutch people in the city. That is a picture of Rick, and Rick is the tall person, and there he was encouraging Dutch people to vote. And the last is an event they have this week encouraging World Bicycle Day. Rick, do you want to say a few opening words?
Well, thank you very much. Yes, and indeed, I'm a tall person. How did you find out about that? Yeah, thanks a lot, Joe. Thanks a lot. It's wonderful to be here as the embassy, and it's impressive that so many alumni of Dutch technical universities have found their way to Switzerland. We have quite a turnout, I see. Let me first start off just explaining what we do as an embassy, because that's not clear to everyone. We're here to help Dutch citizens, Dutch companies, and knowledge institutions, and Dutch interests here in Switzerland. So we do some of the consular affairs. That means renewing passports and helping people that have been jailed here in Switzerland and things like that. And you've seen the pop-up embassy that we've organized to help Dutch citizens apply for new passports, because now that the corona situation is improving, suddenly there's a boost of people that want to travel again. We do a lot of political affairs, public diplomacy, so reaching out to the public here. Climate diplomacy is also a part of our work. But a lot of our work as well is trade promotion, economic cooperation, and investment. And a big red thread throughout all of that is innovation cooperation between Switzerland and the Netherlands, because we are both very innovative countries, open economies, and our ties when it comes to innovation are extremely close. Just an example, within the Horizon Europe program, which you may know, Switzerland works together with no other European country as much as it does with the Netherlands. And the same goes inverse as well. So a lot of bilateral and multilateral innovation cooperation in that sense. What we do as an embassy then is to connect those ecosystems and see what are some of the things where we can benefit from each other, where we can innovate together, and see how we can link those two up. And of course, my colleague Bart is also here, joining in from Berlin as the innovation attaché, and we work together very closely in that regard. Thematically, important themes for us are indeed startups, but also quantum, CERN itself, life sciences and health, HTSM, artificial intelligence. So those are all areas in which alums of Dutch technical universities are very active. And that's also one of the reasons why I'm so happy to be here tonight, because I'd like to ask you, if you identify any opportunities for the Netherlands, if you observe interesting developments, or if you have interesting contacts in those fields, please let us know. We'd like to see you as our eyes and ears. You are all, in fact, ambassadors of what the Netherlands has to offer. So help us help you, and please help us a little bit as well. If you want to reach us, as Joe said, we're quite active on social media. You can reach us via LinkedIn or via Twitter, of course, but you can also just send us an old-fashioned email. It would be nice to hear from you, and hopefully we can also meet in person very soon. I'll just leave it at that. Joe, back over to you.
Perfect, and thanks a lot, Rick, and we'll make sure to include contact details for both you and Bart in our follow-up email after
Appreciate
the
it.
event. Okay. Let's give you some information about the Dutch Engineers Alumni Network, DEAN. So the 4 universities in total have 380,000 alumni around the world. And obviously most of them live here in the Netherlands, but a bit over 60,000 live outside of the country. And you can see On the slide, the concentrations of alumni where we have deemed communities. So Germany, the Nordics, Spain, Australia, the USA, UK, and France. Below that, you see Switzerland, 2,500 plus alumni along with the concentrations. And these are some of the major employers. Obviously we have a lot of alumni working in research, but also in the IT companies, banking, chemicals, and so on. What's going on in the TUs? Well, since the focus is on entrepreneurship and the timing of our event is so close to 4 other events happening, we thought it'd be cool to focus on what are we doing with entrepreneurship. And each of our universities really encourages students to develop their skills as entrepreneurs. And we all have competitions every year where students over a period of a few months can develop their startup ideas, get advice from alumni and companies, and the best startups are chosen and hopefully companies come out of it. So in front of you on the slide, you see some events that are taking place in the next 2 weeks. That'll be the final stage of these competitions. And this is an example of one startup that was created in the Delft competition this year. And let me show you a short video featuring one of the co-founders, Simon Brinksma. So I'm gonna put that right now.
Welcome to the biosphere, our precious oasis in the universe. Although she is our only home, we are quickly exhausting her resources, changing the climate and destroying her wildlife. We desperately need a new way of doing business.
Hi, I'm Simon Brinksma, founder of Biosphere, a clean tech startup with the goal to develop and distribute sustainable innovation. Our first focus is energy. The challenge of our age is to go from 5 to 100% renewable and bring power to the 2 billion people worldwide who don't yet have access to reliable electricity. Now, we get plenty of energy from our sun. And with solar cells, we can turn that sunlight into cheap, reliable, and clean electricity. But the solar energy industry is still using that old make, take, and dispose mindset. Currently, solar panels are impossible to repair or refurbish. When one cell breaks, we just throw away the entire panel. This is a giant waste of resources, energy, and money. Now, I'm working with an amazing team of PV experts, product designers, business developers, and sustainability experts, and we are developing a truly circular solar panel. This is a solar panel that can be repaired once it breaks and can be refurbished at its end of life, so that it's ready for another life cycle. Research points out that with this simple design adaptation, we can reduce the per kilowatt hour cost of electricity by half and greatly reduce the carbon footprint of solar energy. Our panel is made with recycled plastic, and if during its lifetime solar technology evolves, we can simply upgrade it with a new layer of cells.
Yeah, so
Welcome to the
I find it really inspiring hearing students like this. I mean, one of the great things about working at a university is every year we get a new generation of students with that energy and amazing ideas. And in this competition, this is just one example of dozens of other startups that will be pitching over the next 2 weeks. So we'll include links in our follow-up email so you can look into those as well. And I put the slide about alumni benefits after this because we do have alumni involved with the competitions. And that is one of the benefits of being an alumnus of the university, is the fact that you get a chance to work with our students as mentors, as coaches, or tap into our education. So here you can see a list of the different benefits. And again, we will include this in an email with links so you can explore all the different options the universities offer you. And it is now time for Chester's keynote speech. And yeah, so 2 years ago, this TU Delft alumnus was in the 30 under 30 by Forbes Switzerland. And before that, he won TU Delft's Best Bachelor Award with his team. And he was also active student who in his sailing group, he was in charge of the sandwiches. I found this in a video, but he really has had an interesting journey from his Delft days to where he is now. And I think I will pass the digital stage over to him. Chester, can you take control?
Definitely. Thanks very much, Joe, and also for the kind words. I'm thrilled to be here with all of you tonight and to have the opportunity to speak to all of you. Let me figure out how to share my screen. Here we go. I think you should be able to see something.
Yes, we do.
Amazing. Yeah, so just to start, a little bit of background on me. So I've been, I wasn't able to participate in the poll, but I've been in Switzerland for almost 7 years now, although I had some stints also abroad in between. But I'm very Dutch. I grew up in a town called Baarn, close to Hilversum and Amersfoort. And finally did a bachelor's in mechanical engineering in Delft before doing a master's here at ETH. And as Joe referred to, about 3.5 years ago, together with 2 others, I founded a company called 90 Labs, and that's what I'll tell you more about in this talk. But before I go into that, it's maybe interesting, since it's a night where we share about entrepreneurship, that I was thinking back about my Delft time, and in fact, I actually started my first company during my Delft time. Kind of when I think back about my student room, I think about cardboard boxes full of plant pots that were made out of cow manure. That was one of the first businesses I started. And we were trying to sell these plant pots to different do-it-yourself chains and garden centers and web shops throughout Europe. Yeah, to different levels of success, some successful and some unsuccessful, given the fact that if my mom is where some of these cardboard boxes ended that were not sold at my mom's place, if she's cleaning up, then she still finds some of these plant pots full of cow manure laying around. So I hope that the journey with 90 Labs ends differently. To jump in, I'm starting with this picture, and being with Dutch, even during COVID, I would assume that you think that this might be a festival tent that's soon going to host thousands of people, but in fact, this was the car assembly, or the one of the car assembly lines for the Model 3 that Tesla was in the initial phase of production of in 2017. And that the company put up in 3 weeks on its parking lot right in front of its factory. And at the time, I was actually not working. So after my ETH, I spent a year with Tesla. I was not working in the tent itself, but on the factory floor inside the building, connecting software to robots. But what I took away from this experience was basically that automation within the manufacturing world is really difficult. Even a big company like Tesla with such a lot of resources at the time was not able to meet production numbers, and the automation took much longer than expected to hook up all the robots. So they essentially built an entire assembly line that was mainly manual outside of the factory. But the second thing I took away was that to bring super high-tech products and make them affordable and put them in the hands of a lot of people, automation is really necessary. And that's what also kind of was the seed to what we currently do at 90 Labs, where we don't automate the manufacturing of cars, but of a lot of other cool applications that I'll share more of. I'll start with this slide where you see 3 everyday objects, and at a first look you might think that they don't have that much in common, but actually they do. On the left you see a seat structure of a structure of an aircraft seat, in the middle an iPhone, and on the right a car. And for different reasons, engineers, while designing these parts, were looking to create a super lightweight solution. So on the left, in the seat structure, the big driver is to have essentially a lower airplane, which reduces CO2 because the airplane in the end uses less kerosene. In the middle, you want to have a lightweight, also thin system to carry with you anywhere. And on the right, you see a car where at the moment, the main driver for lightweighting structures is to increase battery size so that the range of an electric car increases. And so what all these objects have in common is that engineers in the end ended up using metals to satisfy the requirements for these applications, although they had to be very lightweight, because in fact there is a material that is much more destined to be used in lightweight applications, and this is a material called fiber reinforced plastics, or composite materials, sometimes also named. I was actually introduced to this during my bachelor's, as Joe said, my bachelor project, of whom actually one of my teammates is also in this call. Super nice that Lily is also here. We were introduced to the composites, to the composite materials. And to really quickly explain what it is, it's basically different types of fibers. It can be glass fibers or carbon fibers. You can have also even like volcanic rock fibers. But basically what you do is you place fibers inside a plastic, and by smartly orienting them based on certain boundary conditions, you can create a really superior parts to metal, and especially for lightweight applications, it's very much used. So you can create in the end a part that's basically as light as plastic, but as strong as metal. And this is something that industry already knows, because in planes, this is already the go-to material. The latest planes, the A350 and the Boeing Dreamliner 787, the majority of the fuselages and wings are already made out of composites, and also in high performance road bikes, in drones, and in prosthetics. You see this material being used, but these are always very high-end applications, and the obvious question is, why is this material not being used more in day-to-day objects? And to give you an answer to that, I'll take you on a journey to India. Not that India is so let's say so known for composites, but for me this was what gave me the insight. So I actually went backpacking after Delft to India, and in a train I met a really passionate engineer who had 2 of his children working for NASA in the US, and who told me about such strong Indian ecosystem and Indian network, and he encouraged me to go work for one of India's prides, a company called Tata Advanced Materials, which makes parts out of composites for the aerospace industry. And so this is a company just outside of Bangalore, and this is on the top left. You see here the facade of the building, and the nice glass facade hides what's inside. Where in fact there's a lot of manual labor involved in making these parts. And just to highlight that this is not specific to India, also, for example, Fokker in the Netherlands, that is a big producer of composite parts, also still use a lot of manual labor to make parts with this material. So essentially how it works is you have a fabric, much like what your clothing is like, and you orient fibers according to a load case, place it onto a mold, and oftentimes you have to also do a curing step afterwards with big ovens and autoclaves. So this was for me the first kind of touch point with how rudimentary still the production of this material is, and gave me the insight, hey, if we want to make this material much more available to everybody, we need to do something, and that's something we started doing here at ETH with my 2 co-founders of 90 Labs. One of them was at the time doing a PhD on this topic, and basically we looked at, okay, how is currently the whole industry changing, and how is automation and digitalization influencing engineers to make decisions on what kinds of materials they are using in their process. And just to because I think a lot of people are familiar with what automation is. That's something, since the 80s, a lot of, for example, milling machines have been computerized. but especially from the last 20 years, what's really necessary if you want to bring a product into high volume production, you need to think about the digitization or the digital environment as well. And this starts from the engineer actually designing parts, being able to do first validations without producing the components, so doing simulations in a virtual environment, being able to do continuous releases so that you don't have every year or every 2 years that a new car comes out or a new bicycle, but then you can swap components on the go and quickly send those orders to your suppliers by having supply chain integrations or different software integrations to make sure that you can also have high volume production running even while doing continuous releases. And the last thing is part traceability. So this is knowing even after a part has been in a car or a plane, when it was produced, by whom, on which machine, with what material, so that you can also do, for example, if a failure happens, you can more effectively improve the production process. And so this was basically the idea that we started with at 90 Labs. This is one of our early pictures in the first few months. You see here Giovanni, one of my co-founders, and one of our early employees, Filippo, on the left, that were working with our first systems. And as said, so one of my co-founders worked on composite 3D printing, which essentially brings the automation into the composite space, but it also increases the design latitudes of the parts that we can create. So what we are able to do, so for example, this part I have here, traditionally metal, we can actually make it 80% lighter if we make it out of composites. And so kind of coming from, or startups oftentimes have this software or this, or let's say if you go look, okay, how do we build a startup? How do we do this? The first thing people advise you to do is make a product as quickly as possible, get feedback, iterate quickly, and see where you can get. And that's basically what we did. So we created an initial prototype, we created an initial software, and we started reaching out and selling a first number of prototypes into different industries. And so we soon thought we're going to make parts for all these different industries. We're going to be soon making parts for satellites, for sailing boats, for mountain bikes, in the car industry, sunglasses. We're gonna carbonize the whole world. But we could also quickly realize that in fact the building a startup with, or like a hardware startup, is very different than building a software startup. And just to explain you kind of the thought process we went through at the time, I use a metaphor. I'll use this metaphor, which I think is really powerful in explaining how this works. So on the left, you see an artwork being made by Pollock and his wife Lee Krasner in the background, and on the right you see the casting of a bronze sculpture. And there's really a big difference in how you approach getting to your result in the end. So what Pollock was able to do was basically take a blank canvas, put some stripes here and there, some colors, add some paint, take a step back, look, together with his wife, look at what they thought. If they wanted to add a little bit more color here or there, or add some more elements, and they could quickly iterate and quickly change. Whereas obviously when you're making a bronze sculpture, as you see here on the right, where the bronze liquid is poured into a cast, you need to first really think about what you're creating before you're gonna melt the bronze and cast your sculpture. Because if you don't do a good job, you're gonna have to make another cast. And so this kind of gives the analogy between software and hardware, where in hardware we had to really think hard before we went into sprinting what exactly we were doing. And the other thing we realized was that we were in fact not just a hardware startup, but we were also a hardware startup in very regulated industries where people's lives are actually on play, and all parts that go into, say, airplanes, for example, have to go through a really rigorous qualification process. And so basically we were casting a bronze sculpture while we had a jury looking at us and giving us grades and notes. So that made us rethink. So roughly after a year, we thought, okay, how do we really structurally do this to be successful? And gave us 3 takeaways. The first one was we should really focus on a few industries where we know our solution makes sense, because in the end, every industry has slightly different requirements, slightly different qualification processes, and obviously resources are limited. The second thing we learned was, or we said, we have to focus on applications that have short development cycles, because we want to still get feedback relatively quickly. We cannot wait for an aerospace program, which might take more than 10 years to know if our part is actually going to be used in a plane. And lastly, we focus on those things where we can really make a difference. And for us, that meant that we focus on the technology, meaning the software and the machines that make them, but we don't actually make the parts. And how that reflects in real life is that we are currently going after 3 industries. One is aerospace. This is an industry that traditionally has already seen a huge shift from metal to composites. Already in the last 30 years it happens, but it was limited to only the big structure, so the fuselages and the wings. Whereas the smaller parts that you see mostly in interiors, but also many supports and brackets, it was not economically possible to make these out of composites. And with now our technology, we can finally also make these smaller parts out of composites. Then in the middle, for us, industry we'd never thought of initially, medical. Obviously also being in Switzerland with a strong pharma, but also a medical device industry. It made us open our eyes to see that actually composites are used quite a lot by surgeons in operating rooms. And the reason they use this is that besides it being very stiff and strong, is that you can do imaging while you have these tools around the body. So a typical device is an aiming arm where a surgeon positions a drill in a certain orientation before screwing something into a bone, for example. And during this surgery, you want to be able to do X-ray imaging. And that's why composites are used, because composites are X-ray translucent, whereas metals are not. And this industry, how it opened our eyes was one day we were walking on the parking lot here in Switzerland of one company, and the CEO pointed to a pile of waste material, literally worth hundreds of thousands or even millions, because these people, what they've been doing is just taking a block of composites and essentially milling away all the material they didn't need. So for us, it was a very clear area where we should focus on. And then lastly, we have leisure and luxury. This is mainly watch cases, sunglasses, where we can do really cool things with 3D printing, having a lot of control of our fiber. We can, for example, have a pattern like a mountain landscape on one watch case, and on the next one a waterfall. So it's mainly kind of marketing driven, and we can super quickly get to serious production in this industry. The second point on leveraging also other industry partners, so really focusing on what we're good at. We decided to use established material, so we're not going to invent our own material. We're using material that has already been used for many applications in industry, and we work with manufacturing partners that have dozens of years of experience, and that a big aerospace or a big medical company is used to working with. So what's the result? The result is one of the machines that's also standing behind me. We offer a full all-in-one solution that starts with the software on the left, where the part can be designed, can be simulated, and then subsequently you can connect to your devices. We have 2 units. One is the build module, which is actually the 3D printer where the part gets made. And then we have a second unit that post-consolidates the part, so basically applies pressure and heat again, so that we can secure the quality needed for really mass production. but also we can have design latitudes that were not possible in composite manufacturing before. So where do we stand now? We actually just at the end of last year, we moved into a new workshop. We finished development of this first industrial system and are now assembling the first units to be delivered to customers soon. We are at the moment about 30 people, and we're planning to grow to about 50 by the end of next year, to be able to have to go after all these customers in all these varying markets. We're actually also in the process of doing another fundraise to also do this. And basically, what drives us and what kind of like the really exciting opportunities are ahead of us, I'll share with you now. So one of the fields that at the moment we're very excited about is a field that maybe not all of you are familiar with. It's what most people call urban air mobility, or like electrical vertical and takeoff and landing devices. This is something where a lot of money is being put in. Last year, only 2 billion was invested into different startups around the world. And basically, the idea is that it's a new way of transport for people, inter and intra-city. And the expectation is that the first ones will be flying in 2023, and production numbers will be really significant in 2030. And why this is so interesting for us is that, let me go to the next one, is that as said, the production volumes are much higher than in traditional aerospace, and our process is really made for that, and the parts are much smaller. So we see this as really relevant, and we expect the first parts to be going into production in 2023. Then another really interesting area for us is smart wearables. So with the advance of VR, AR, but also smartwatches, for example, sensor integration and integrating also batteries in the casings has become a much bigger topic. And to still be able to offer a nice fitting case, using a really thin and strong material makes a lot of sense. So this is a space that we're also really active in, and the first parts are going into production in 2022. And lastly, the two big markets for us are exoskeletons and surgical robotics. So exoskeletons, obviously the population is aging, and this means that we'll have more and more people that need body supports that need to be lightweight. And in surgical robotics, as I already said, surgical instruments is one, but especially the fact that there's more and more robotics being used also during operation means that there's going to be more and more imaging, which will require more and more of these X-ray translucent parts. Then to conclude, I'll conclude with this looping, which for me is symbolic for, I think, the main lesson we've learned over the last 3.5 years, which is that progress is not a straight line. If I go back to one of the first slides I started with Tesla and the production tent, then this always gives us the let's say the motivation to keep going, because even if such an inspirational company is sometimes struggling, we have essentially, or what we have done as a culture is really embracing this fact that progress is not a straight line, and we as soon as you accept that this is how it works, you have a lot more energy to just keep moving. And with that, I'd like to thank you all very much, and looking forward to share more in little break rooms, I believe.
Hey, Chester, but before we go to the break rooms, we have questions for you. So
not letting me go yet.
First an applause, Joe, I think.
Yeah, definitely.
Thank you, Chester.
Hey, first we have a question from Case. Case, do you want to unmute yourself and ask your question?
Absolutely, no problem. Hi, good evening, and thanks for this organization. First of all, I wanted to ask about standardization, because some of the industries you have mentioned are heavily regulated and standardized. The manufacturing processes you come up with in your company, have they hit any curbs or roadblocks about standardization, and how did you solve that?
Yeah, brilliant questions. Basically, like the main point I think we answered in the, let's say, the first year or two. So basically what we do is, especially the second process step, where we use this, it's essentially a compression step, a pressure step, where we apply pressure and heat to the part. This is a relatively standard process in industry. And this is what basically ticks off many of the boxes that you need. So if you go into the technical details, like for example, the void content in a part, by having this second step, we make sure that this is at the required standards. And another aspect is, for example, this material. So we use materials that companies already use already in mass production, so that element of the value chain doesn't have to be certified.
Okay, and the aspect of less people in the loop during the process, did that hurt you somehow?
I think like less companies and less points in the whole process is actually more of an advantage. Is what we have seen.
Thanks, Justin.
Chester, we have a question from Irvin. What made you decide to put your energy into a startup rather than an established company where you could have done something similar? For example, Tata.
Or Tesla.
Or
Had
Tesla.
I stayed there, that would have been good. No, I'm super happy to have left Tesla at the time. No, I think it's also in the end, it's what excites you and what do you want to do. And at the time, I also thought about what are the kind of projects that have always excited me. And I think Peter Thiel wrote this book 0 to 1, and I think that's very much describes how I feel that this initial step is really exciting. And then once the wheel is spinning, I think there's still a lot of challenges, and I don't know, maybe in the future I will also be more excited about that. But I think at the time, that was really what made me do this.
Okay. Here's another question. Do you guys at 90 Labs also build products to see how to build parts, components to those markets?
Yeah, absolutely. That's actually the let's say big part of the sales process as well. So typically what we do is we look at the part portfolio of one of our or of a potential customer. So we look at all the types of either composite or metal parts that they manufacture, and we see where our technology can really offer a benefit. We typically do a full feasibility study to show them what it would mean if they would implement our technology. And then typically what we actually do is we manufacture a part. So this, for example, part that's actually it's for an automotive company. And then from there, we usually they have to do some testing internally to make sure that everything is right. And then we go to actually delivering machines.
Okay. Hey, Chester, can you stop sharing your presentation for a second so we see your face in natural size? Always better to see big heads. Now, and of course, now I lost the chat window. Come on, because we had one more interesting question. Okay, supposedly you focused on 3 areas, but we have a question from Marco. The medical application looks very attractive for your application. Why not capture this market? Why also focus on other markets that are so much different?
Yeah, also a brilliant question. I mean, in the end, it's risk return. Like obviously you can focus on one application really early and go after that completely. What we have decided is to also early on kind of spread or at least spread to other markets that we believe are also interesting in the long term. Because if you don't start building relationships and start also doing initial projects in other industries, it's going to take you much longer to get there in the end. So that's why we have a number of focus areas. We see mostly the applications making the difference, not so much the industry per se.
Okay. We also had a question about exoskeletons, asking, wouldn't there be a bigger market for the military or factory workers who do heavy repetitive lifting? Or is it still in experimental medical phases?
Yeah, no. So yes, exactly. No, so maybe exactly. I put it under medical, but indeed, exoskeletons are often used also for other types of body support, like actually defense is also we're not really active in defense, but that's also where exoskeletons are used a lot. But yeah, also in factories indeed.
Okay, and we have time for one more question. So the quickest person to unmute themselves can take the honor. Is there a question? Going once, going twice. Well, in that case, I'll just ask Chester a question he knew I was going to ask. Why 9T Labs?
The name.
The name.
Yeah, sometimes you need to think harder when you come up with these kind of things. Now, basically, it's a little bit of a joke with 90 in English, so like 90 degrees. And the really, let's say, groundbreaking thing that we do is that although we 3D print within one plane, we can orient fibers out of plane. So if you look at this part, we have fibers both in this orientation as well as in this orientation, and we can do any orientation in between as well. But so it represents this 90-degree or up to 90-degree out of plane manufacturing of fibers, and that's what still is like really the let's say what differentiates our technology from some of the other 3D printing technologies out there.
Mm-hmm. Actually, that's a pretty good explanation for a name, Chester. So I'd be pretty proud of that.
I have 2 or 3 other ones as well, but all these explanations only, they only come up once people start asking it.
Mm-hmm. Okay, well, let me hand things over to Mechtold to do the final thank you.
Yes, Chester. As per tradition, as we like traditions within the technical universities, we've got a very modern thank you gift for our speakers for these very nice lectures, events, to our alumni volunteers. And it's especially designed for the TU Delft alumni. And this is a one-of-a-kind pair of socks for you, coming all the way over to Switzerland. You cannot buy it in a TU shop. This can only be acquired by giving voluntarily your time, talent, and effort to the TU Delft. So thank you very much for your very nice keynote tonight. And this will be coming your way.